Okay, this is a typical problem. When you're being introduced to completing the square, you're not solving for it yet. You're understanding the relationship between a perfect square binomial and a trinomial. So these are the typical instructions, and let's look at typical problems you might see. X squared plus 4x plus blank equals. Your goal is to make it into something squared. So let's look at it geometrically now. This is obviously 3 by 3, but it can represent an arbitrary x value. Now, the key part of understanding this is I'm always going to break up the linear term into two parts, two equal parts. It's kind of based on this observation. Okay, so I'm going to make this 2 and this 2. Okay, and let's complete these rectangles. So I have x squared here, 2 times x gives me 2x, and I have 2x here. So as you can see, you can kind of think of it as I've rewritten this, or I've re-represented this in in a geometric form over here. Let's fill this in. Okay. Now we want to literally complete a square. So just look at it visually. What part is missing? Well, if I completed this, it would obviously be a square, and it's clearly a 2 by 2 square. So area 4. I mean, it's literally 1, 2, 3, 4 units, four unit squares. So if I add the quantity 4 area, if I add a square of area 4, I'm able to literally have a square with sides x plus 2. Okay, similar example. Let's just go to the next case, x squared plus 6x. Okay, so it's choosing, arbitrary value of 4 as x, and I'm going to break the 6x into 3x and 3x by doing this. So this is 3 and 3. This gives me x squared. This is 3x. And this is 3x. So literally, I want to complete the square. So if I had a 3 by 3 square with an area of 9, that would allow me to have a square with sides x plus 3. Interesting. Let's continue this for a while and see if we can observe a pattern. Now let's have x squared plus 8x plus blank equals. Okay? So this is my x. I gotta make it this way. Okay, so this is x and x. Now we want to break down the 8x into 4 and 4, 4x and 4x. So 1, 2, 3, 4. Okay, so since this is 4, I have 4x here, x squared here. Well, if I had a 4 by 4 square, I would be able to make it a square. Right? If I had this region over here, which is a 4 by 4, which is composed of 16 square units, I would be able to have a square made up of x plus 4, with size x plus 4, I should say. Interesting. Let's do one more and try to observe a pattern. So, x squared plus 10x. So because I'm probably going to run out, let me do this one. So this will make my x. I'll put it inside because I'm running out of room. And I'll make, so I want to break the 10x into 5x and 5x. 1, 2, 3, 4, 5. right? So finally have enough room. So as you can see, this is going to be 5 and 5. So this is x squared. This is 5x. This is 5x. Let me just underline it to make it clear. Okay, so if I had a 5 by 5 square, I would be able to complete this. I'll be able to make a square. So if I add the quantity 25 squared, I'll be able to have a square with sides x plus 5. Now let's look for a pattern. Let's go back at our previous examples and look at a consistent pattern. Notice how if I take half of the linear term, which is 2, this value, c, is always the square of this, and this number always matches this. It's consistent throughout. Half of 6 is 3. 3 squared is 9, and then the 3 and the 3 match. Let's look at, so half of 8 is 4. I'm going to put it on top. 4 squared is 16, and then the 4 and the 4 match. So it's a consistent pattern. It always works that way. Again, half of the 10 is 5. 5 squared is 25, and then this 5 and this 5 match. So ask yourself, do you want to keep making squares, or do you observe a pattern? So let's try it without making squares this time. Right? Based on our pattern, we know what to see. So if I take half the coefficient of the linear term, I have two things I'm concerned about. This is going to be 6 squared, which is 36, and then it's going to be x plus 6. Let's move on to 16x. Again, half the linear term, coefficient of the linear term is 8. 8 times 8 is 64, and then we have x plus 8. This is really about, I hope this appeals to your intuition, and you don't want to keep drawing squares, so you're ready to just use the procedure now. Now, the geometric argument is slightly different if the coefficient of the linear term is negative. However, the same process works. So since we're so comfortable with the process, let's just do it that way. So for example, what I mean by that is, you'll see the difference because we have a negative over here. So I still take half the coefficient. So this time it's negative 3. Now, negative 3 times negative 3 is 9. So the 9 goes here. And the only difference is I have x minus 3 as opposed to x plus 3. X squared minus 8x. So half of negative 8 is negative 4. I add this negative 4 times negative 4 is positive 16. And this simply becomes x minus 4. Okay, so let's do a few concluding examples. I don't want to make the numbers too big. I think I skipped 14, so I'll do that. And let's do one last negative one. So some people like to put the, just to keep track of things, to put the 10 over here. So you can do that, you don't have to. 10 times 10 is 100, and I make it x plus 10 squared. And half of 14 is 7. 7 times 7, 49, becomes x plus 7 squared. Half of negative 18 is negative 9. I square this to get positive 81. And I do x minus 9 squared. So with practice, you do this without thinking, and you're reassured that it works based on the geometric argument.